you get a negative. So we're going to get a negative solution over here. Let's try this. So negative meaning negative radicand. So x squared plus 1 is equal to 0. I need to isolate the x squared. So I'm going to subtract 1 on both sides. So x squared is equal to negative 1. Then we square root both sides. Bless you. So we square root both sides, and we get x is equal to plus or minus the square root of negative 1. Right? And as you recall, I is equal to the square root of negative 1. So that means x is equal to plus or minus I. Okay, so you will get problems like that. Let's look at these 4 examples. Okay, so the first problem, we have the square root of both sides, right? So let me write it over here on the left. X squared is equal to 5. And when you square root both sides, don't forget to write the plus or minus, 2 solutions, right? So x is equal to plus or minus root 5. Let's do the second one. In the second one, we have x squared minus 2 is equal to 0. First, we got to get the x squared isolated, so we add 2 to both sides. And you get x squared is equal to positive 2. Then you can square root both sides, and you get x is equal to plus or minus radical 2. For part C, we have 9x squared minus 8 equals 0. So first we add 8 to both sides, and we get 9x squared is equal to 8. Then we can divide both sides by 9. So we have x squared is equal to 8 over 9. Next we square root both sides, and we get plus or minus, right? So don't forget, you could separate these, right? Radical 8 over radical 9. And this simplifies further, right? So radical 8, did you get 2 root, well, it's 4 times 2, so it's 2 root 2, right? So did you get plus or minus 2 root 2 over 3? Hopefully that's what you got. Last one, we have x squared plus 9 equals 0, so we subtract 9 to both sides. We get x squared is equal to negative 9. And when you square root both sides, you can see that this becomes what? Square root of 9 times the square root of negative 1. That's your I, right? So 3i. So we get x is equal to plus or minus 3i. Any questions or problems with these? Alright, let's move on. We're going to do the square root method or property for something a little more complicated. As you can see here, we have the problem the quantity of x minus 5 squared minus 5 equals 0. So I'm going to actually write that over here on the right hand side and do it as I explain it. So you see how this is a quantity squared with the x inside the set of parentheses? So we have to isolate that first, right? Any term that doesn't have x, we're going to move it to the 5 to the minus 5 to the other side. So now we have x minus 5 is equal to positive 5, right? And to get rid of a square, right, we would have to square root both sides. Okay? Now, this square root will cancel out this square. You don't really get this part. All we did was add 5 to both sides, and then we square root both sides. Does that make sense? So look at this. This is now x minus 5 is equal to plus or minus radical 5. Is that part clear? Because we're trying to solve for x, right? So now we can add 5 to both sides. So x is now equal to 5 plus or minus radical 5. Okay? So that was the first problem. Let's look at the second problem. The second problem we have here is 9 times y plus 1 squared minus 2 is equal to 0. So we have to get this by itself. So I have to add 2 to both sides. And that's what we get, right? Now, I don't want to square root this just yet. I want to get rid of this 9. So this is multiplied by 9, so we divide both sides by 9. Right? When we divide both sides by 9, we get y plus 1 quantity squared is equal to 2 over 9. So now we can square root both sides. So square root with the plus or minus. So on the left-hand side, you have y plus 1 is equal to plus or minus. I'm going to simplify this. This is radical 2 over radical 9 is 3. Do you remember that, right? You could separate the two radicals and simplify the radical 9. Last step is to subtract 1. So y is equal to negative 1 plus or minus root 2 over 3. So now it's not conventional to leave answers like this when there's another fraction. So what we do is we combine these. Let me move down a bit. So the way you combine it is take the LCD. The least common denominator is 3, right? So we would make this negative 3 over 3. Right? This is negative 3 over 3 is your negative 1 plus root or plus or minus root 2 over 3. So what would that look like as one fraction? That's negative 3 plus or minus root 2 over 3 is your solution. We have two solutions, right? Negative 3 plus root 2 all over 3 or negative 3 minus root 2 all over 3. Okay, let's try a few examples. I'll leave that up on the left-hand side. You can try these two, and we'll go over them. So we have to add 3 to both sides, right? And now that x minus 2 squared is alone, we can square root both sides. Don't forget this is plus or minus. So the left-hand side, this is all cleared out, and you have x minus 2 is equal to plus or minus radical 3. Okay, and then finally you can add 2 to both sides, so you get x is equal to positive 2 plus or minus radical 3. And you want to write the non-radicals first here. Okay, so I'll give you a minute to finish up the second one. So we notice that the 3 is already on the right-hand side, right? So I can go ahead and divide this 4 to both sides, right? And we have x minus 1 quantity squared is equal to 3 over 4. When this is at the point where you can square root both sides. So I got x minus 1 is equal to plus or minus the square root of 3 over 2. Right? I separate these into two separate radicals and add 1 to both sides at the end. When I add 1 to both sides, we need to combine this into one radical, right? I mean one fraction. So since the denominator is 2, this is the same thing as saying times 2 over 2. Right? So now this is 2 plus or minus radical 3 over 2. And that's our solution. How many people got that? 2 plus or minus Radical 3 over 2. Well, now we're going to learn how to complete the square. And we're going to utilize this, um, what we just learned, right? The square root property to solve by completing the square. So we have a quadratic equation, x squared plus 8x minus 7. And instead of using factoring or any other method, we're going to learn how to complete the square. So first, I want to move the constant, this constant negative 7, to the right-hand side. So we're starting off the same way, right? And when you add 7 to both sides, you get x squared plus 8x equals 7, right? Now this is the important part here. So you have your a is equal to 1, right? Your b is equal to 8. And what you're going to do is you're going to take your b and divide it by 2, or multiply by half. So when you take your b, make sure you keep the sign. It's positive 8 times a half is equal to 4. We're going to go with that, right? Next, we're going to keep that 4, but take that 4 and you're going to square it, and you get positive 16. Now the 16 is what I add to both sides of the equation. So this is what we had earlier. We had x squared plus 8x is equal to 7. I'm going to add 16 to both sides. So I get x squared plus 8x. I'm going to add 16 here and add 16 to the right-hand side. See that? 7 plus 16 is 23, right? Now the cool part is we just completed the square. This is now a perfect square trinomial. And remember how we were discussing a plus b squared is equal to a squared plus 2ab plus b squared. Same for a minus b squared is a squared minus 2ab plus b squared. So these are perfect square trinomials. So this is actually a binomial squared, which are these two formulas. So this will factor into what we solved here when we did the 8 times half. This is going to factor to x plus that 4 quantity squared. Does everyone see that relationship? Right, if you took this binomial and you squared it, you get x squared plus 8x plus 16. Okay, so that's what completing the square is. You take your b, you multiply by half, you square it, and add it to both sides. Okay, now we square root both sides and get the plus or minus, and we have x plus 4 is equal to plus or minus radical 23, and lastly, you subtract 4. Okay, so I know that seems a bit complicated, but I hope everyone realizes what just happened, right? You take the b and you multiply by half, square that answer, add it to both sides. So this is the 16 that we added to both sides. Let's try another one. Okay, in this problem we have x squared minus 6x minus 2. So we're going to add 2 to both sides to get the x's by itself. So x squared minus 6x is equal to 2. Now off to the side, I'm going to take this negative 6 and multiply by a half to get negative 3. Okay? Now this negative 3, I'm going to square it and add it to both sides. So I have x squared minus 6x plus 9 is equal to 2 plus 9. You see how I balance this equation by adding 9 to both sides? Okay, now this negative 3 that we got earlier over here, this is going to help us. This factors, this is now a perfect square trinomial. This will factor to x and then that negative 3. X minus 3 quantity squared is equal to 2 plus 9 is 11. So this is the hard part. People have a hard time seeing the factoring part here. This factors, right? Doesn't this x minus 3 squared, doesn't that equal x squared minus 6x plus 9? You see that? This is called the perfect square trinomial. And that comes from our a minus b quantity squared. Remember this? A squared minus 2ab plus b squared. Okay, so now that we have this factored, we can square root both sides with the plus or minus. So x minus 3 is equal to plus or minus radical 11. Then lastly, we add 3 to both sides, and we have our two solutions. 3 plus or minus radical 11. How was that? Now the constant is already on the right-hand side. So I'm going to take my b, which is negative 2, and multiply it by half. And we get negative 1. This negative 1 needs to be squared, and we get positive 1. Did everyone get positive 1? That's what we add to both sides. Add 1 to the left-hand side, add 1 to the right-hand side. Now, this minus 1, that's what this factors to, right? This is y minus 1 quantity squared is equal to 9. Right? And at this point, we can square root both sides and get y minus 1 is equal to plus or minus 3. Okay, and then lastly, add 1 to both sides. So y is equal to 1 plus or minus 3. Now because 1 is a like term with the 3, we have to actually simplify this. So we're going to get y is equal to 1 plus 3, right, which is y equals 4, or y is equal to 1 minus 3, so y is equal to negative 2. Two solutions, y is equal to 4 or negative 2. Did everyone get that last part? Okay. Oh, you didn't get the last part? What did you mess up on? So I'm going to move the constant term to the right-hand side. Subtract 13. I get x squared plus 10x is equal to negative 13. Now, the b is 10, right? So I take 10 and I multiply it by half, and I get 5. Next, I take the 5 and square it and get 25, which is what I add to both sides of the equation. So x squared plus 10x plus 25 is equal to negative 13 plus 25. Is that clear? Now this is because we added 5 squared is 25 to both sides. We just completed the square. This is a perfect square trinomial. And this will factor into this 5 that we got by multiplying half to the 10. So we got x plus 5 quantity squared is equal to positive 12. Now we can square root both sides, and we get x plus 5 is equal to plus or minus. If you remember, radical 12 is radical 4 times radical 3 is 2 root 3. So plus or minus 2 radical 3. Lastly, we subtract 5. So x is equal to negative 5 plus or minus 2 radical 3. And because these are not like terms, you cannot do anything else. That's the final answer. So we have x squared plus 4x plus 13 equals 0. So the first thing we need to do is move the constant term to the right-hand side. So this plus 13, we subtract 13. So we get x squared plus 4x is equal to negative 13. And then we take our positive 4, right? Multiply by half to get 2. And then take the 2 and square it to get 4. This 4 is what we add to both sides. So x squared plus 4x plus 4, and then negative 13 plus 4. So this is now a perfect square trinomial. What this factors into is the x plus 2 that we got from here, this 2. So x plus 2, quantity squared, is equal to negative 9. Now, as you can see, when we square root both sides here, right, we get the square root of negative 9 is the square root of 9 times the square root of negative 1. That's why we get 3i, right? So x plus 2 is equal to plus or minus 3i, which is right down here. Lastly, we subtract 2, and we get x is equal to negative 2 plus or minus 3i. Two solutions, and this is in our standard form, a plus or minus bi. Now let's try our own example. We have x squared plus 10x plus 41. So the first thing we need to do is move that constant over. We got x squared plus 10x is equal to negative 41. Then we take our 10, multiply it by half, we get 5. We take 5 and square it to get 25. And 25 is what we're adding to both sides. So we got x squared plus 10x plus 25 is equal to negative 41 plus 25. Now this is our perfect square trinomial. This factors to x plus 5 quantity squared. And we get that 5 from here, right? The 10 times the half. Negative 41 plus 25, that's negative 16. We can take the square root of both sides. So we have on the left, x plus 5 is equal to plus or minus. Now this is 4i, right? If you forgot, negative 16 is 16 and negative 1, right? And 16, radical 16 is 4, radical negative 1 is I, okay? Finally, we subtract 5 on both sides. We get negative 5 plus or minus 4i, and that's in our standard form, a plus bi. We move the constant term to the right-hand side, so we got q squared minus 8q is equal to negative 20. Now, we take our b, which is negative 8, multiply it by 1/2, and we get negative 4. Next, we take that negative 4 and we square it to get positive 16. Did everyone get positive 16 there? Because if you didn't, you would get the rest of this problem wrong. Very good. Now we add that 16 to both sides. So plus 16, negative 20, plus 16. Now this left-hand side is a perfect square trinomial, which factors into q minus 4. That minus 4 came from the negative 8 times half, right? Is equal to negative 20 plus 16 is negative 4. Next, we square root both sides, right? And we get q minus 4 is equal to plus or minus 2i. Are you all comfortable simplifying this radical now in your heads? Right? Negative 4. Square root of negative 4 is the square root of 4 times the square root of negative 1, which is 2i. Right? Lastly, we add the 4 to both sides, so we get q is equal to 4 plus or minus 2i, and that is our standard form, a plus bi.